Today we're going to be doing AP Calculus section 3.7 and I'll be trying to guide you through how to do differentials. So first we're given a function f, and this function at -3 is equal to 4, and its slope at -3, its derivative, is equal to 2. So using this we had to find an approximation for f of -3.15 by using the tangent line of the graph at f. So what that basically means is that we have to use the tangent line, which is y minus y1 equals m x minus x1, and they give us the point. It's at -3 comma 4, and they give us the slope at -3, which is 2. So just plugging that in, y minus 4 is equal to 2 times x minus -3, so plus 3, and that's just y minus 4 equals 2x plus 6, and then that's equal to y equals 2x plus 10. And they want us to approximate the value at -3.15. So now instead of x, we're just going to have y equals 2 times -3.15 plus 10. And that's equal to 3.7. Okay, now they give us a point at -5 comma 8, and the slope at that point is -7. So we have -5 comma 8, and our slope is -7 because that's the derivative at -5. So y minus y1 would be y minus 8 is equal to -7 times x minus -5, which is plus 5. So y equals -7x minus 35 plus 8. So y would equal -7x minus 27. And we're trying to find the approximate of f of -5.1. So y equals -7 times -5.1 minus 27. And that's equal to 8.7. Same thing here, where our point is going to be 1 comma 2, and our slope at 1 is going to be 9. So y minus 2 is equal to 9 times x minus 1. So y is equal to 9x minus 9 plus 2, and y is equal to 9x minus 7, and our approximate point here is going to be y equals 9 times 0.95 minus 7, which is equal to 1.55. Okay, now here they give us basically the same problem, except instead of giving us, say, f of something like a number like 5, they just give us the function f prime of x. So you have to solve for that instead, but still they give us f of -5 is equal to -9, so we know that our point is -5 comma -9. But now f prime of x, so now we have to find f prime of x at -5. So 2 times -5 plus 8 is equal to -2. So our point is going to be -5 comma -9, and our slope at that point is going to be -2. So y minus y1 would be y plus 9, and that's equal to -2 times x plus 5. So y is equal to -2x minus 10 minus 9. So y equals -2x minus 19. And plugging in -4.9 to approximate, we get y equals -2 times -4.9 minus 19. which is equal to negative 9.2. Okay, now we're given the same thing here. Our point is 3 comma negative 6, and our slope at this point, if you plug in 3 into negative 2x plus 2, you get negative 4. So y plus 6 is equal to negative 4 times x minus 3. So y is equal to negative 4x plus 12 minus 6, or y is equal to negative 4x plus 6. And if you plug in 2.8 into there, you get negative 5.2. Okay, same thing here. Our point is negative 1 comma negative 10. And if you plug in negative 1 into f prime, you get that your slope is negative 6. So y plus 10 is equal to negative 6 times x plus 1. And that's equal to y equals negative 6x minus 6 minus 10, or y equals negative 6x minus 16. And if you plug in negative 1.2 into there, you get negative 8.8. Okay, so now we're given this question where we have f of x equals 5x to the 2/3, and we have to approximate f of 1.15 by using the tangent line at x equals 1. So what we know is that we have to use the tangent line at x equals 1. So our point is going to be 1 comma something. We don't know that yet, and we don't know our slope yet. So to find our y value, we're just going to plug 1 into here. So 5 times 1 to the power of 2/3, so 5 times 1 and to the power of 2/3, which is basically 1 squared, and then that, or you can just say 1. So 5 times 1 is 5. And now to find our slope at that point, we do the derivative of 5x to the 2/3, so 5x to the 2/3. And doing the derivative of that, we get 2/3 times 5 times x, and 2/3 minus 3/3 is negative 1/3. So that's our derivative, and if we plug in 1, we have to plug in 1 now, so 5 times 2, 10 over 3 times 1 times 1 over cube root of 1, which is 1 over 1, or just 10 over 3 times 1. So our slope at that point is 10 over 3. So now we have everything that we need to know. So we can do y minus 5 is equal to 10 over 3 times x minus 1, and y is equal to that. So plugging in 10 over 3 times, now we're approximating 1.15, so we plug in 1.15 minus 1, and then add 5. Our point is 5.5. So tangent line approximation is 5.5, and our tangent line is going to be y equals 10 over 3 times x minus 1 plus 5. Okay, so now for this second half part of the equation, we have to find the second derivative, and we have to find when x is over or less than 0, the second derivative is over or less than 0. So doing f double prime of this, which is our first derivative, we get negative 10 over 3x to the negative 4 over 3. And we can see that if you plug in values that are over 0, then you're going to have a negative value. So when x is over 0, the second derivative is less than 0, which means that f is concave down, like this, and that means that our tangent lines are going to be overestimate. Okay, so now we're given the function f of x equals 5x to the 4/5, and we have to approximate f of negative 31.85 using the tangent line at x equals negative 32. So at x equals negative 32, our y value would be plugging that in to 5x to the 4/5, so 5 times negative 32 to the power 4/5, and that is equal to 80. So 32 comma 80, and our slope at that point, so 5x to the 4/5, and doing the derivative of that, we'd get 4 over 5 times 5x to the negative 1/5. So now plugging in 4 times negative 32 to the power of negative 1/5, you'd get negative 2. So our slope at that point is going to be negative 2. So, and this is our first derivative. So now we can do y minus 80 is equal to negative 2 times x plus 32, and our approximation at that point would be negative 2 times negative 31.85 plus 32 and plus 80, so 79.7. And our equation would be negative 2 times x plus 32 plus 80. So now finding the second derivative would be negative 4 over 5 times x to the negative 6 over 5, and plugging in a number that would be less than 0 into this, you'd get a negative number. So when x is under 0, the second derivative is less than 0, meaning that it's concave down. So the point would be an overestimate. Okay, so now we're given the function f of x equals negative 5x to the 2/3, and we have to approximate it at negative 1.15 using the tangent line at x equals negative 1. So at x equals negative 1, our function negative 5x to 2/3 is equal to negative 5. So that's our point. And the slope, we have to find the first derivative of this function. So negative 5x to 2/3, that's equal to negative 10/3 times x to the negative 1/3. So that's our first derivative. And if you plug in negative 1 to that point, you would get this, which is also equal to 10 over 3. So our slope at that point is 10/3. So y plus 5 is equal to 10/3 times x plus 1. And if we plug that into a calculator, using x equals negative 1.15, we get negative 5.5 for our predicted number. and our tangent line is approximately equal to y equals 10 thirds times x plus 1 minus 5. And now the second derivative of this would be 10 thirds times x to the negative 4 thirds. And if we plug in a value like negative 1 here, then we would get a positive value, meaning that when x is under 0, the second derivative is over 0, meaning that the graph of f is concave up, and tangent lines there would be less than, so it would be an under approximation. Alright, thank you for joining me today for differentials.